My dear student, welcome to School of Fundamental Sciences, SOFS. I deliver some fundamental concepts of physics, chemistry and mathematics for JEE Main and JEE Advanced. It will give me great pleasure if you enjoy this concept. Now, today I will discuss part 4 and part 5 of calculus for physics. Up to part 3, I have discussed calculus by old maths, that is called concept of, by using concept of limits. It is actually mother of calculus, limit concept. You can go inside, you can observe everything what is happening there. Now we must have shortcut method, that is called new maths. In new maths, from actually limit concepts, we have made lot of interesting operations. We will apply these operations to find the rate of instantaneous rate or maximum value, minimum value, etc. by using different operation. Yes, in a new math, that is called by shortcut method. Now first you see, to find the suppose instantaneous rate for suppose example for a displacement x as a function of time, so we can find the instantaneous rate of change of displacement, that is called dx dt. Similarly, if we have the velocity as a function of time, we can find the instantaneous acceleration as the rate of change of velocity at the moment of time t, and that can be obtained by the concept of differentiation. Now this dx dt or dv dt, they are called derivative or differential coefficient. To find the differential coefficient, we need the concept of differentiation. Yes, I will discuss how to have differentiation to find the instantaneous rate of change, etc. Now before that, the derivative dx dt, dv dt, etc. is associated with sign of the derivative. For example, you see, if a particle moves with a decreasing velocity, for example, yes, then if we have a dv dt, since velocity decreases, dv negative and dt all time always increasing, so dt positive, so dv dt is a negative quantity. Similarly, if the particle is accelerating, that is the increasing velocity, then dv also positive, dt also positive, so dv dt will be positive. Now from the concept of limit, we have obtained some fundamental theorems of differentiation. You see, theorem number 1, law of constant, that is ddt of k, then ddt of k is equal to 0 when k is a constant. Or the commutative law, the ddt of commutative law, ddt of k into ft where k is a constant equals what, k will be taken out, so k ddt of ft, it is a commutative law. Similarly, if you have a distributive law, so ddt of suppose k1 f1t plus minus k2 f2t, etc., then again we can apply ddt of k1 f1t plus or minus ddt of k2 f2t, then k can be taken out, so we will have k1 ddt of f1t. Similarly, plus or minus k2 is taken out, ddt of f2t. Yes, it is a distributive law. Similarly, we can have a product rule and quotient rule. You see, accordingly we can have product rule and quotient rule. But here mainly we will use law of constant, commutative law and distributive law. Now, to facilitate differentiation, we need another rule, that is called chain rule. Yes, you see, if we see that y is a function of t and t is a function of x, and we like to find dy dx. So y is a function of t, so we cannot find dy dx, we can find dy dt. T is a function of x, so we cannot find dt dy, rather we can find dt dx. So you see, we need dy dx, but f is a function of t, so we have dy dt, and t is a function of x, so we need dt, we have dt dx. So you see, chain rule, dt dt cancel out, dy dx remain as it is a chain rule. An example, suppose acceleration equals to, dv dt. Yes, when the velocity is a function of t. Now we like to find the acceleration when the velocity is a function of x. So let us see. Acceleration a is equal to dv dt. There also we can write dv dt cannot be operated because v is not a function of t, v is a function of x. So we have dv dx. Now adjust, it is dv dx, and if we multiply dx dt, so dx cancel out, dv dt remain as it is. It is a chain rule. Dx dt, dv dx, so dx cancel out, dv dt remain as it is. But dx dt is equal to v, and dv dx remain as it is. So acceleration will be equals to very important v dv dx when velocity is a function of x. Similarly, by applying limit concept, we have obtained some useful fundamental results, that is called fundamental derivatives. Like result number 1, ddt of t to the power n is equal to n t to the power n minus 1 where n is a constant. The proof you can have from mathematics book. Here we need only result. We will apply result to solve physics problem. Similarly, you see ddt of, if it is a ddt of t to the power n, simply n t to the power n minus 1. But if you have ddt of ft, then again we have substitution. Like just imagine ft is equal to z to the power n. So it will be changed to d dz dt. So d dz z to the power n means what? N z to the power n minus 1. Z is equal to ft, just to remember, into d dt of z. It is shortcut tactics. Also you see proof. Proof you see by method of substitution. By method of substitution you see d dt of ft to the power n is equal to, we have replaced ft by z. Z is equal to ft. So z to the power n. So d dt operation not possible. So we have our d dz z to the power n dz dt. Chain rule. Dz cancel out, d dt remain as it is. So d dz z to the power n is equal to what? N z to the power n minus 1 dz dt. So n z is equal to ft to the power n minus 1 d dt of z is equal to ft. Proved. Similarly, we can establish other results also. Just you see other results, then you can realize like this: d dt of a to the power t equals to a to the power t ln a. Ln means log a to the base e. Obviously, a greater than 0 because ln of positive quantity can be defined. Ln of 0 or negative quantity cannot be defined. So ln a means a must be greater than 0. It is simplest form. And once you have a complex form, we need method of substitution or successive differentiation. You see here also d dt of a to the power ft equal, what will happen? Think this to be z. D dz a to the power z means what? A to the power z, that is a to the power ft ln a into d dt of z. Similarly, you see d dt of et equal to e to the power t. Just you put replace a is equal to a by e. So d dt of e to the power t is equal to what? E to the power t ln e. Ln e is equal to 1. So e to the power t. Similarly, d dt of e to the power ft is equal to e to the power ft into d dt of ft, like this. Just you think this ft is equal to z. So d dz e to the power z is equal to e to the power z. That means e to the power ft into d dt of z. Always think in this way. Similarly, we can have result 3 also. You see result 4. You see trigonometrical result. d dt of sin t is equal to standard result cos t. So again, if you have a ft, d dt of sin ft, then think this ft to be z. So d dz sin z is equal to cos z, means cos ft into d dt of z, that is d dt of ft. Similarly, here also you see d dt of sin omega t plus phi. Think omega t plus phi is equal to z. So d dz sin z is equal to cos z. Just imagine z is equal to omega t plus phi. Right here omega t plus phi into d dt of z. So d dt of omega t plus phi. Now it is a distributive law. d dt of omega t is equal to only omega plus phi is equal to 0. So omega is taken out, cos omega t plus phi. Similarly, we can have cosine results also. Now one sample problem. X equals to cos square ln t. We have to find dx dt. So you see dx dt is over d dt of, what is the x? Cos square ln t. Equals to, you see the cos square ln t cannot be differentiated. So we will have the what? Cos ln t is equal to z. So it will be z square. So d dz, z square means 2z. So 2z means cos ln t into d dt of z. So d dt of cos ln t. Chain rule. Now 2 cos ln t. Again you see, again you consider ln t is equal to z. So d dz of cos z is equal to standard result minus sin z. So minus sin ln t into d dt of z. So d dt of ln t. Also chain rule. Or it is called successive differentiation. You see our short videos for successive differentiation. So minus 2 cos ln t sin ln t and d dt of ln t standard result 1 by t. Now we know 2 sin ln t cos ln t is equal to what? Sin 2 ln t. We know 2 sin x cos x is equal to sin 2x. So you see here also minus sin 2 ln t 1 by t answer. Now practical problem, applied problem. a particle is moving along the x-axis with the velocity as a function of x given. V is equal to 4 meter to the power what? Second to the power minus 1 root x. Be careful, the constant has a dimension. How to get this? Left side you see meter per second. So 4 root over x equals to also meter per second. So you can have the dimension of 4. So what is the 4? 4 is equal to meter per second by root over x. Root over x means what? Root over meter. And accordingly you can find the what? Dimension of SI unit of 4. Again you see V equals to meter per second. So you see clearly it is root x means what? You can verify also root x means what? Meter to the power half. So meter to the power half and meter to the power half is equal to meter per second. So V is equal to meter per second. So it is meter per second, it is also total meter per second. So from here you can find the dimension of V. Now we have to find the acceleration of the particle. So since V is a function of x, so we must have this equation. A is equal to V dv dx, already given because V is a function of x. What is the V? Put the value is set. ddx of, dv dx means ddx of V, ddx of, again put the value of V here. Then 4, this and this remain as it is. Here it is a constant, commutative law taken out. So ultimately 4 meter to the power half, second to the power minus 1 whole square, because 4 and 4 whole square, root x, ddx of root x. ddx of root x is what? X to the power half. So half x to the power half minus 1. That is 1 by 2 root x. Root x cancel out because it is not equals to 0, greater than 0. So we will have 8 meter per second square answer. SP10. The displacement of the particle as a function of at any moment of time is given. Root 2, root x equals to this, it is given. We have to find the acceleration of the particle. So root x is given, squaring both sides, so x equals to square. So V is equal to dx dt is equal to ddt of x, put the value of x. Then you see again, consider this to be z. So it is z square. So we need d dz z square dz dt. So d dz z square means 2z, z is equals to this, into d dt of again z. So this remain as it is. This. Come here, it will be what? d dt of this equals to what? Commutative law, 2 meter to the power half, second to the power minus 1 taken out. d dt of t is equal to 1 and it is 0. So ultimately we will have this 2. From here we have 2 meter to the power half, second to the power minus 1, and this remain as it is. So what is the acceleration? A is equal to dv dt is equal to what? ddt of whole. Now it is constant taken out, commutative law. ddt of this one. Again you see, again ddt of this one, you will what? This 2 is taken out, ddt of t 1 plus 0. So ultimately 2 meter to the power per second coming out from here. So ultimately we will have 8 meter per second square. Now SP11. A particle oscillates along the x-axis according to this law. It is actually problem of simple harmonic motion. We have to find the acceleration of the particle as a function of x. So first displacement x is given. Yes, so velocity dx dt equal to what? ddt of whole. So 0.05 meter is taken out, commutative law. So ddt of this one. There is 0.05 meter. Now consider this to be z. So d dz sin z is equal to cos z. ddt of z. It is z. 0.05 meter. Now from here we will have 5 per second. ddt is equal to 1. So 5 per second is taken out. Cos of this one remain as it is. So what is the acceleration? dv dt. This remain as it is. ddt of this one. Again think this to be z. So d dz cos z, dz dt. d dz cos z means minus sin z. So minus sin z. And ddt of this z is equal to what? 5 per second. So multiplied 5 per second. So ultimately equals to, we have this sine of this one. Now you see equation number 1, 0.05 meter sine of this equals to x. So we will have 25 second to the power minus 2 into x using 1. So this is the acceleration as a function of x.